Hi, my name's Hayley Norman from CSRO Livestock Industries, and I'll be talking about the economic and ecological reasons why we might revegetate saline land. There are several ways we can measure the economic value of saltland pastures. The first is paddock scale comparisons. These are simple and we tend to just compare grazing days per hectare. Infrastructure costs tend to be disproportionate, however, and they don't explore integration across enterprises. Whole farm economic modelling, such as the Midas model, while complex, allows us to explore changes and synergies across the whole farming system. It does, however, model an average farm in an average season, so it may not be applicable to your farm. In terms of paddock scale comparisons, I'll talk about some of the data from the SGSL WA1 project, where we compared unimproved saltland, so really barley grass country, with saltbush based farming systems. There's some data here from a site at Tammin on Tony York's farm and a site at Yellering on Chris Walton's farm. If we have a look at the two farms, Tammin and Yellering had similar rainfall, although during the comparison period Tammin only had 290 millimetres while Yellering had 340. In terms of depth to water table, Yellering has a much shallower water table than the Tammin site. However, the Tammin site, the water table was 1.5 times seawater salinity, whereas Yellering was only half seawater salinity. Tammin also had a pH of 3, so a fairly nasty groundwater, versus Yellering with a pH of 4. In terms of how we improved our saltland pasture, we planted Old Man and River saltbush seedlings at about 700 stems per hectare, and we planted annual legumes, including subterranean clover, Burmetic, Balanza clover and Persian clover, at about 8 kilograms per hectare. So this was really a commercial plantation, not a scientific plantation. We had poor establishment of the legumes at the Tammin site. It was way too salty for the legumes, so it's, remember that as we move through the data. And at Yellering we had a much better establishment, although we had a poor establishment in the first year. A lot of hard seeds seemed to regenerate in 2005. Both sites were grazed with merino wethers in autumn, and here you can see a photo of the sheep on both of those sites. We measured live weight and condition score changes as well as wool growth from those animals. In terms of the data in grazing days per hectare in autumn, you can see at the Tammin site there was very little difference between unimproved saltland and the saltland sown with our saltbush and understory, and that was in all comparison years, with about 200 to 400 grazing days per hectare. The Yellering site, we can see a dramatic result from the revegetation of the saltland pasture, with 3 times the grazing days in 2006 and 4 times the grazing days in 2007. In terms of wool growth, there was no difference at the Tammin site with 3.1 kilograms per hectare, but at the Yellering site we had nearly double or more than double the wool growth, with up to 5.2 kilograms per hectare during that grazing period. So from our paddock scale comparisons in the SGSL project, we determined that revegetating the better classes of saltland can triple carrying capacity. Obviously that was revegetating the Yellering site, tripled carrying capacity, while sites like the Tammin site, which were very harsh and low rainfall, we didn't get any benefit from that revegetation. Understory is important, obviously, and it's better to start with the good saltland and then move down the slope as the good stuff starts to pay for itself. Now, how does this fit within the whole farming system? I'll now talk about the Midas economic modelling. We've got here data from the Central Wheat Belt model, and this was on one axis we've got whole farm profit, and on the other we've got shrub area proportion of the farm. So what the model's trying to do is look at different proportions of shrub on the farm and how that will influence whole farm profitability. If we use a typical farm in the Central Wheat Belt, 11.5% of the farm is classified as having poor soil. And if we look at what shrubs do on that part of the farm, you can see that about 10 to 20% of the farm under woody shrubs, in this case saltbush, would optimise profitability of that farm. Now, if you've got more poor soil on your farm, so in a highly saline area such as Tammin, the first thing you notice is the farms are less profitable, but you also notice that you're better off putting more of the farm into shrub area, and that curve flattens off across the top here. So if you get in 10% or you get in 30%, you're really not going to start to lose profitability dramatically. Now, what if you've got a farm with very little poor or very little saline soil? Obviously you're going to make more money, but then there's a higher opportunity cost for revegetating that soil with saltbush. So you're probably down near to just about 10% of the shrub area of the farm to optimise profitability. So what is this Midas modelling telling us? It's really saying that we're increasing farm profit by utilising the poor soils on the farm. And that's through out-of-season feed production, particularly protein, through the summer and autumn. That's allowing us to increase our carrying capacity across the entire farm. And we're spelling pastures at the break of season, so moving animals onto the saltland during the break of season to allow the better pastures to get away. And it also tends to demonstrate less supplementary feeding of animals. So we're saving about 2 kilograms of grain per sheep by having the saltland pasture on the poor soils. What the model isn't quantifying, and these are also powerful reasons to revegetate saline land, is we're getting more and stronger wool from the saltland pasture. That's the saltland pasture is helping us to prevent wool tenderness during autumn. We're spending less time feeding animals in autumn by putting them all in the saltland pasture, and we're keeping sheep off cropping soils at the break. It's also allowing improved visual amenity, and as you can see from this photo at the Yillering site, the saltbush-based pasture looks a lot nicer than barley grass flats. We've also found a lot of benefits in terms of ecosystem health, and I won't go through the data, but we're seeing benefits in terms of wind erosion, shelter, and providing habitat to native animals. So here are some photos we've captured, one of a bungara living in the saltbush, nearly gave me a heart attack. Another is a lot of chats and other birds use the saltland for nesting sites, and here we can see a little lizard that we found in our saltland. We're also seeing benefits in terms of the invertebrates that live in saltland. So saltland appears to be sheltering a lot of bugs that are quite good for cropping systems, so bugs that help to remove the sap suckers from crops. We've also seen healthier soil biota. The soil under the saltbush-based systems has higher microbial activity than the barley grass paddocks, and also increased native plant diversity. A lot of the native plants that aren't found in our cropping and annual pasture systems are starting to creep back into the saltbush-based systems. And at the Tammin site we had 40 native plants colonising that site. Also, the saltbush-based system appears to keep the salinity from spreading, and Richard George's data from the SGSL Yillering site shows that saltbush at 700 stems per hectare has led to a 50% reduction in water flow from that site and only 10% of salt export. So the saltbush-based system appears to keep the salt in the spot rather than exporting the salt into rivers, and also that's helping to drop the water tables, and that's allowing the annual legumes and more salt-sensitive species to survive. So in conclusion, revegetating saline land can improve whole farm profit, carrying capacity, particularly through the autumn feed gap, ecosystem health and visual amenity. In another webinar we'll talk about how we manage it to optimise animal production and health. Thank you.